Hi friends, as you have seen in previous session, right? Already you know that there is a drawback in central tendency measures, right? Like in that example of apple and pumpkins, you have seen that mean is not correct measure, right? Because the central tendency it won't help in that example, right? So for that reason, we are coming to next one called as variability measures. Okay, next topic is variability measures. Okay, so anyway, previous video race you can link is provided in this. Okay, if you are watching first time. So first variability measures. Next in that the first one is range actually. Range means it is a maximum value minus minimum value. Suppose if you take 5 values like this 1, 2, 3, 4, 5, then maximum value is 5, minimum value is 1. So 5 minus 1 it is 4. In this case 4 is the answer for the range for these values. But here there is some problem in this, there is some drawback because why only it is using only two values, right? Only minimum, maximum and value, two values only. Its subtraction it is taking. Another problem is it will be influenced by outliers. Means in this example, for example, some 100, suppose any value 100 will come. Then in that case 100 minus 1 it will become 99. But it is not correct value, right? Because if any outlier means unexpected value if it comes, then it will become big problem. So that is one of the drawback for range. So that's why it is not very useful range actually. So that's why there is another thing called deviation. Here deviation means it is a difference between the observed value and the other value. Okay, for this formula is sigma xi minus mu divided by n. Here xi means actual value like x1, x2, x3, x4, x5 in this example, minus mu. Mu means average actually. Here you see mean is the right, that is what average here, x minus mu divided by n, that is number of observations. Okay, so in this example this x minus mu, this is called as deviation from the mean. Deviation means here x1, suppose x1 means x1 how much far from the average, then suppose next value x2 how much far from the average, then x3 how much far from the mean, x4 how much far from the mean, x5 how much far from mean. So this will give deviation from the mean, how much far it is. Then you are dividing with actual number of values. In this case 5 values are there, and with 5 will divide. That is, if you do it like that, then you are getting deviation. So before that, for mean we have not seen the formula, right? For mean this is the formula. Mean is sigma xi by n. Means in this case x1 plus x2 plus x3 plus x4 plus x5, that is 1 plus 2 plus 3 plus 4 plus 5 divided by 5. That is what average, right? So like this will represent mathematically. So mu is a mean, sigma xi means x1 plus x2 plus x3 plus x4 plus x5 divided by n. This is mean formula. But for deviance, what is the formula? This one, sigma xi minus mu by n. So if you compare what is the difference, you can see that only one extra thing, that is minus mu is coming. Means, as I mentioned, this is the deviation from the mean. From the mean, your actual value how much far. So your actual value how much far means this how much deviation from the mean. From the average value, your first value, that is x1 how much far, plus sigma means plus, right? Okay, then x2 how much far from the mean, then next value x3 how much far from mu, plus like that you will add x4 minus mu, x5 minus mu divided by 5. So if you calculate this one, you will get the deviation. Okay, but here this is the deviation, but there is another one more useful thing called variance. Variance means here see, in the mean it was talking about central value, right? But whereas variance will talk how the data is spread, it will talk about. Okay, so this variance is how widely individuals are varying in the data in the group actually. Means in the group individuals values how it is varying, this is what variance will give. So you may be wonder why it is called sigma x square. For this symbol is given a sigma square because it is a square of the your deviation. What is the deviation formula? This one. So it is square of that. Square means for this whatever value is there here, for that we are making square. So that is the reason sigma square is given. Okay. So for variance there is one drawback actually. For variance there is one drawback, that is it is very hard to interpret, because in the previous pumpkin example points is the value, right, for measurement, but points square will come. There is no meaning, right? Points square, because units are squared, there is no meaning actually. So that is the reason it is very hard to interpret variance. So that is the reason what we do, it is square is taken, right? To compensate this we can take square root. That's what in the next formula square root they will take to compensate this square. So that is what standard deviation. Why? Because this deviation variance is not very means very hard to understand. That's why this deviation they came with some standard. What is the standard? Simply the square root they did for the actual square, which means what is the standard deviation? So it will be square root of the variance. What exactly standard deviation means? It is the average distance to the mean. Average distance to the mean. In this case, what is this one? Deviation from the mean. But deviation from the mean is not very good, but whereas average distance from the mean will be good to mean. So this is the formula. Okay, so here it is very more meaningful actually, because units are in pounds, right? So units are in pounds, that's why it is very standard, means very good standard to use actually. So to very quickly to summarize, so in central tendency, because in that pumpkin example it was not very good to take every time mean as a means as a center value you can take, but it won't help in those cases. So that is the reason it is come up with another thing called as variability measure, means how data is varying. So not only just simply average value, it's not like center value we are worried, we want to know how exactly all the data is varying in that group. That is what. So for that reason, first we have seen range, that is simply max minus min, only two values it will take. That's why it is not very useful. So that's why we went another one, deviation. So that will actually it will take each value, how much distance from mean it will take one by one. Then it will add up all the values, the differences it will add, and it will divide with actual count. That is what deviation. But the thing is, not only deviation, how much overall variance is happening. To know that, simply we are doing square of that and we are getting. But problem is units are becoming square. That's why still we are means not okay with that variance value. That is the reason we went to another measurement called standard deviation. Means this deviation became very standardized by making square root of the variance. So in the formula, if you observe, there square is was there. Here square root we have taken again. So square root if we cancel, so something like that, units will become pounds. Okay. So this is the idea here. Okay, so if you like the video, please like it. Okay, we'll see you in the next video. Please subscribe if you are watching first time. Thank you.